Hello guys, welcome to the new video, which will be the next part of the previous video that I've already uploaded. It is about the solution video of the physics sample paper of JEE Advanced released by IIT, unofficially released by IIT Kanpur, because IIT Kanpur is also organizing JEE Advanced 2025 officially, which will be tomorrow. So due to time constraints, I won't be having time to separately upload videos for solution videos for section 2, 3, and 4 of that paper. So what I will be doing is that I will be doing a sprint run on all the three sections, solutions for all the questions in the three sections, and I will be uploading this in this long video. So I'm just giving a disclaimer before that because this will be a long video, but I will be posting timestamps in that video so that you can maneuver through the video and reach anywhere at any point or any question that you want to see the solution of. It will be easy for you, and I'm sure that before the exam tomorrow, this solution video might provide new thoughts and approaches in your mind, which would be like helpful in tomorrow's exam. I wish that. So let's get into the video. So let's begin with the first question of section 2. Section 2 has multiple correct answer type questions where you can have multiple answers, and the marking scheme, as you all know, is +4 -2, and there are also partial marks for whatever options you mark out of the correct options. Okay, so you know about this marking scheme, so I'm not going to brief about them. Let's move to the first question of this section. Okay, so question 5 says a particle of mass m equal to 1 kg is initially at rest at the point x naught, y naught, which is 0, 0. The particle is subjected to a force F equal to alpha t I cap plus beta j cap at time t equal to 0, where alpha equal to 2 Newton per second and beta equal to 1 Newton. The angular momentum and torque acting on the particle with respect to origin in SI units are represented by L cap, L vector and tau vector respectively. Which of the following statements are correct? Okay. So let us first draw the coordinate axis, and we have been said that just at the first at time t equal to 0, we have been applied a force have been applied over time, which is a function of time. So okay, so at any general instant t, let us say my point is here at x comma y. This is x and this is y. So what are the what are the forces and everything acting on it? Let us just point it out. Okay, the I component of the force would be alpha t, and this is beta, and okay, this is y and this is x. So, and this was origin 0, 0. Okay, so let us find out few things. Fx equal to alpha t, Fy equal to beta t. So from here we know that Vx would be alpha t square by 2 plus c1t, and x, if you find x, it would be alpha t cube by 6 plus c1t square by 2 plus c2. Now you have some initial conditions, which is it was at rest. It was at rest uh, at the origin. So at t equal to 0, x was 0, so this would be 0, and now at t equal to 0, vx was also 0. So uh, excuse me, sorry, this would not be t. Yeah, so at t equal to 0, vx was also 0, so basically c1 is also 0. So what you get is you can remove all these things. So vx, your function vx becomes alpha t square by 2, and your function of x becomes alpha t cube by 6. So now similarly find for vy and y. You will find that this will be basically, just a minute, yeah, it is beta, just, yeah. So basically you will find that this is beta t and this is beta t square by 2. All right, so this is my functions about what we are doing, because we need these coordinates and we need to find the time. So for the first option, we need to find torque when the particle reaches the point x comma y. So when x equal to 1 by 3, let us find what the time is at that point. If x equal to 1 by 3, then we can easily say that since alpha equal to 2, okay, we have these values as well. Alpha equal to 2 and beta was 1. Yeah, so if alpha equal to 2, then we can find that t equal to it would be 1 second, right? So at t equal to 1 second, we need to find the torque. So torque would be what? What is torque? Torque is basically R cross F. Am I right? It's R cross F. So if I take k cap, if I take k cap here, which is out of the plane, then my torque for this force, this x component fx, it would be fx times y minus k cap, fx times y. So it will be inside the plane, fx y minus k cap and plus fy x k cap, right? So when you find this, it would be fx time y. My y is okay. My y x equal to 1 by 3 and my y is 1 by 2, right? Okay, so fx was alpha t. So since t is 1, so it would be 2 into 1 by 2 minus k cap plus fy is beta, which is already 1, and it is 1 by 3 k cap. So this is, I think, minus 2 by 3 k cap tau. So this option is wrong. Definitely this option is wrong. And now let us find angular momentum. Okay, we all know what is angular momentum. Angular momentum is m r cross v, right? Now since vx, we can write that vx is also in this direction, vx, and this is vy. We can write this, isn't it? Similarly, just as we wrote the force, we have the components of velocity and acceleration as well. Yeah, so for r cross v, we can similarly do the same thing, which is basically m is 1, right? So m is 1, so we can say that vx y minus k cap plus vyx k cap. So if I put this, vx was alpha t square by 2, which is again, because we need to same thing, so t equal to 1, we need to find it t equal to 1 only. So it would be 1 into 1 by 3 minus k cap plus it would be vyx, which is beta t. So it would be beta is 1. So beta, if since beta is 1, it would be 1 into 1 by 2 k cap. So it is 1 by 2 minus 1 by 3, which is 1 by 6. Just a minute. Yeah. I'm very sorry. X is 1 by 3, no? Yeah. X is 1 by 3 and this is 1 by 2. Y is 1 by 2. Yeah. I'm sorry. Yeah. So this is minus 1 by 6 k cap. So L is minus 1 by 6 k cap. So definitely this option is correct. And just a minute. Let me add a page here. Yeah, so the page is added now. So let us move on to the next option, which is magnitude of displacement of the particle at t equal to 2 second. Okay, so at t equal to 2 second, we can easily find out my x would be alpha t cube by 6. So it would be 2 into 2 cube by 6, which is basically 8 by 3, and y would be beta is 1, 2 square by 2, so it would be 2. Therefore displacement would be under root x square plus y square, which you can find easily. 8 by 3 whole square plus 2 square, which would be 100 by 9. So it would be under root of 100 by 9, which is 10 by 3. So this would be 10 by 3 only. You can find it out easily. And now velocity of particle when it reaches the point x comma y is, okay, x comma y is the same points we've been given. So just we need to find vx and vy, right? This is for t equal to 1 and this was for t equal to 2. Okay, so vx equal to, we have the function of vx, which is alpha t square by 2. So 2 times 1 square by 2, which is 1, and vy is beta t. Beta is already 1 and time is 1, so 1. So therefore your velocity vector is I cap plus j cap meter per second, and not what was given in the option, which is t2 I cap plus j cap. So this is also wrong. So the correct options are B and C for this question. Question 5, the correct answers are B and C. This is the solution. Okay, so let's move on to the second question of this section. Question 6. A conducting square loop of length A initially located at x equal to 0 is moving with velocity v equal to v naught I cap in non-uniform magnetic field B equal to b naught x by x naught k cap. The function of magnetic field has been given and also the vector has been given here. If v naught x naught and A are positive constant and phi x naught is the magnetic flux passing through the loop when its center is at point x naught. Okay, the correct statements are. Okay, so let's first to solve this question, let's understand what's happening. Let's suppose my loop reaches some point here, say after time t. My loop enters here and reaches this point. All right. So my center of the loop is at here, which is been given. It is x naught, and this loop entirely is moving with velocity v naught I cap, which is uniform. It has been given. Now, for flux calculation, what we can do is basically we can what the general method we can also do with the general method that we can take element, strip element, distance x from x naught. Let's do about center because there is symmetry of the system. All right. So because we need the term x naught in the and my answer as well, because there in the function of b there is x naught given. So what we can do is that we can take x from x naught only. We can take x from x naught. So we can integrate from minus a to a at n. So we can do strip dx here, and then we can easily find flux, which will be b into a times dx and its integral. So we can easily do that. There is no issue in that, but we would not be doing that. Let us try and visualize in some concise way what flux is and how we can do it. Okay, so flux is basically this ba, just a minute, it is ba dx, right? We have this formula which is ba dx, and we know one thing, that we know that center of mass of any system, of any like continuous body, we can write it as x dm by integral dm, right? We can easily do that. There is no issue. Is there any issue in that? I hope so. It is not. There is no issue in that. So this is b dot dA, right? Integral b dot dA. Now where dA is the area element. This is the area element which was here. This is dA. So similarly, this is the area element. Now similarly, I can use a term which is the center of mass. The coordinate of center of mass was given as this. The coordinate of center of mass is given as this, xcm. This is for the center of mass, which is the center of mass. Similarly, I can consider an area of a continuous body, of a surface area of a continuous body in a single point, and that hypothetically we can call it as the center of area. And this would obviously have the same expression. You can just use what you saw in case of center of mass. This thing is very useful in many mechanics problem as well as in fluid problem, to calculate force of water in the side of vessels and all these things. This is very much useful. This is called as center of area, right? So if I use this here, my expression would become integral. Now see, this b, well, the function of b was b naught by x naught x dA, right? The function was given already. Now b naught by x naught is constant, so what I have is x dA. And now what I can do, x dA, I can substitute this x dA term here, and I would give b naught by x naught x center of area into integral dA, which is my total area of the shape that we have, and we know that. So we didn't have to figure out about this integration at all, and we get an expression which is general for any kind of body, any kind of shape that we are given in this form of loop. So let me write the flux at point x naught. That can be easily written as v naught by x naught, x center of area, into integral dA, or which is the area. So I can write integral dA as a, right, as let's say capital A, sorry. I can easily write it as capital A. So now in this case of square loop, what I can write is phi x naught is b naught by x naught, and xCA, which is the center of the loop, which I called as center of the loop. Here xCA is what? xCA is x naught. As per the question, xCA is x naught. So easily I get an expression in terms of what I can say in terms of x naught. See, b naught by x naught into x naught into a, because as I said that I have to bring the term x naught in the solution so that I can cancel out in this function, because x naught is involved in this function. So this is the method where I can directly use center of area. So this is where x naught comes, and we can easily say it is b naught into a. So this is where I can easily do that, and my expression here for the square loop becomes x naught into a, which is a square. So my flux at x naught is b naught a square, which is essentially the first option is correct. This is not wrong. This is not correct. Sorry, this is wrong. And now EMF. Okay, what is EMF? EMF induced is minus d phi by dt, right? So if I have to do that, what I can say is that I have a general expression for flux, and also this is minus d dt b dot a. Now area is not changing with time, so what I can do is minus a dB dt, right? Minus a dB dt. So, acha, one thing you have to note, that this magnetic field is defined over all space, over all x. So don't you think that this here there is no magnetic field. So that's why the area is not changing with time. Okay, so only magnetic field is changing with time, or with space, you can say. So what I can do is, basically I can also differentiate this function right here. I can differentiate phi to get this minus d dt of b naught by x naught, x center of area a, equal to, these are all constants, so b naught capital A by x naught dxc by dt. Now just tell me, since this is a translation, so each and every point of this system would be moving with the same velocity which has been given as v equal to v naught I. So xca would be also moving, dxca by dt will also be equal to v naught. It will be moving with the same speed. So this is basically v naught. So my EMF is v naught a x naught v naught. So just see one thing, that it doesn't matter which shape of the loop is, the EMF induced will always be in this format. Alright, so EMF is always proportional to velocity v naught. So I get my last option, which is EMF induced in the loop is proportional to, this is also correct. Now just let me check. EMF induced in the loop remains the same if the square loop is replaced by a square circular loop of radius a by root pi. So since we saw that the EMF induced has the format of this, so only thing that matters now is, because b naught, v naught, and x naught is defined. So if my area is same, then for any loop of any shape of the same area, EMF induced will be same. So for the circle, area is now pi r square, and r has been given as a by root pi whole square. So it is a square only. So the EMF of the square loop would be same as the EMF of the circular loop, because the area is same, which is a square. So this option is also right. So for question 6, we have 3 options correct, that is A, C, and D. Now let's move to the next question, which is question 7. This is also an easy question. So let us read it. A liquid of density rho is slowly poured from a beaker into an empty cylindrical glass of cross-section area A resting on a table at a constant volume rate of V. The beaker is at height h from the table and the water exits the beaker with negligible speed. Let t equal to 0 be the time at which water initially hits the bottom of the glass, and let h be the height of the liquid in the glass at time t. Assuming the water doesn't overflow, which of the following options is correct? P0 is the atmospheric pressure and G is the acceleration due to gravity. Okay. So initially conditions have been given here that V with V, I mean this V is the speed of the fluid. Okay. So this V initially at the topmost point, it has been said that beaker with negligible speed. It is moving with negligible speed. So I'm sorry. Yeah. So this is V equal to 0. Yeah. Let us assume the impact which is making with the at some general time t, at some general time t, say height h has been filled, and so the water which is being falling right now has to make an impact with the already existing water surface, and let us say that the velocity with which it is hitting that is, say, some small v. Okay, and we have been saying the volume rate of the falling of water is basically v. As you can see, just see this curved v, printed v, I can say. And so if this is the volume rate, I can say the rate of mass of water that is creating an impact here, or dm dt, is my what? It would be density into volume. I mean density into volume rate. Sorry. So this is rho v. All right. So my dm dt is rho into v. The v which has been given in the question. So the impact force, the force of impact, would be essentially v, which is the velocity, v dm dt. Am I right? It would be v dm dt. So it would be v times rho volume rate. Okay. Now what is this v? Now we can calculate this v simply using Bernoulli equation, because if you have v, now see, let us, the atmospheric pressure is everywhere. So for applying the Bernoulli equation between points A and B for streamline flow, since we know it's streamline flow, so we can do is P naught plus rho G capital H would be equal to P naught plus rho G small h plus half rho V square. Alright, so you can easily calculate from here that V is 2G H minus H. This is my V, and so the force of impact is basically nothing but rho V into 2G H minus H. This is my force of impact. Alright, now just look for one thing. I have been in the first option, it has been said the total force on the water of the, or total force of the water on the glass. So total force would be what? Basically the force of water, like the force at this bottom, the pressure due to the pressure of the water, force due to the column, water column, plus the force due to impact of water here, right? That is the total force that is actually acting in the system. So this would be equal to, the force due to water column would be equal to P naught plus at any time the amount of liquid which has been filled, which is P naught plus rho gh, and the impact force at that time is 2g h minus h, that we have already found out. So F total at h equal to h by 2 is what? P naught plus rho g h by 2 plus rho v, it would be h by 2, so it would be rho v root gh. Am I right? So this is my force at h equal to h by 2. So the first option is, okay, just wait, I made a mistake. Since area is given, I have to also multiply with area, because this is my pressure, right? So I have to multiply by area also. So I have missed a term here. Just a minute. Yeah, so my force would be rho v 2g h, just a minute. Yeah, it would be gh for h equal to h by 2 plus p naught a plus rho g h by 2 into a. So this is my force. So my first option is definitely correct. And now when h tends to, I can easily see when h tends to small h tends to capital H, my force of impact becomes 0, but my total, like my force of water column is same, which remains this, and it would definitely my total equal to my, that would be equal to my total force also, due to the force due to the water column. So that would be equal to P naught A plus rho capital G H into A, when H tends to capital H. Okay, so this is definitely not correct. Now total force of the water on the glass increases with H. Okay, so for this question, let us analyze this function which we have already written here for total force. Just visualize one thing. As soon as, like, when the height was, like, this is my force of impact, right? So when H was zero, so it was coming from a great height, so the velocity was also the highest, or the force of impact was also the highest. But as and when water started to fill up, the velocity of impact and the force of impact also started reducing. So as and when H increased, force of impact reduced. But on the other hand, force of water column when H was zero, you can see. And as in when H started to increase, force of water column started to increase. So my force of water column started to increase. So what basically, let us try and analyze it, that since when the force of impact was there, something was there, force of impact at the very beginning, and then it started to decrease. Second part, which was the force of water column, which was contributing to the total force, it started to increase. All right. So there would be some. Now let us think about the rate of increase and decrease of these two terms. All right. Uh, this is a linear function with h. So if I calculate f dash wc with h, it would give me some constant value c. So this is my rate of increase of uh, fwc, and this is not a linear function. So if I just calculate the derivative of this would give me something as a function of h only, right? This would provide me as a function of h only. So you can easily see that at some point of the time, the rate of increase of the water column would be equal to the rate of decrease of the force of impact at some particular height h, right? So what I mean to say is that initially the force on the water, the force of the water on the glass would be basically increasing, because it is primarily dominated by the force of impact that is being generated due to the falling water. But as soon as the force of impact starts reducing, the rate of decrease of force of impact would soon be equal to the rate of increase of the water pressure due to the water column. And as soon as they would be equal, so it would basically overpower the increase of the force due to the impact. So what would happen, that initially the force of the water will be increasing with h, but after some time the force will again start decreasing. All right, after some time the force will again start decreasing, and this would result to basically increasing and a decreasing graph like this for the force of the water. So there will be some maximum where the force of the water at some particular height h, where the force of the water is maximum. You can basically analyze, or simply if you cannot analyze this like this, you can also do the mathematics by calculating f dash total and making it 0 and finding the height, which is basically where it, it would be maximum. So you can check the extremums of this function. So by that also you can analyze it, and you will see that it would not be increasing with all h, like it would not be it is not a strictly increasing function, basically what I mean to say is. So you can easily find out what I'm saying is right. So this will not be a correct option. Option C is not correct in this case. And the impact force of the water on the glass h, on the glass when h equal to capital H by 4, it has been given f not equal to rho v by, just let us check what if it is right or not, because we have the function of force of impact of water, which is f impact at h equal to h by capital H by 4. So this would be equal to rho v 2g h minus h by 4, which is 3h by 4. So we can easily see that this would not be correct, because it would come root 3gh by 2. So this would not be correct at all. So here only option A is correct, as I can see in this question. So in question 7, only option A would be correct. Okay, so let us now move into the next question, which is question 8. It is a capacitor problem, and it's quite a nice problem, to be honest. An easy one though. Okay, a capacitor consists of two circular parallel plates, both with radius capital R separated by distance d, where d is much less than R. The top plate is connected to a constant voltage source at potential V, capital V, while the bottom plate is grounded. Then a thin and small disk of mass m with radius small r, which is much less than both r and d, and thickness t, which is much less than r, is placed on the center of the bottom plate as shown in the figure. Assume that the space between the plates is in vacuum with the dielectric constant epsilon naught. The plates and the disk are made up of perfect conductors, and inductance of whole circuit can be neglected. Okay, good. So you have to find the correct statements. Nice. Now we have to first write. Let's check because there are so many conditions, so many variables. So just write a common relation that all states fixes all of this, which will be t is much less than small r, which is much less than d, and which is much less than again r. So this is my relation here. So this has been mentioned so that we don't have to care about the fringing field effects. So we don't need to care about this fringing fields. All right. So in this question, my voltages have been given. This would be obviously 0. This is V, and this is again 0, and this is V. So my plates are between V voltage. So this is V, and C, capacitance of this plate system is A epsilon naught by small d. So the charge accumulated in the disk, in these disks, would be A epsilon naught Vd, and my area is obviously pi r square. So it would be pi r square Vd, and the electric field. And now if I have to calculate the force, because you have to find the magnitude of the force between the plates before inserting the disk. So just when this was a simple capacitor system, so the force we know it would be sigma by 2 epsilon naught, which is the electric field acting on this capacitor plate, which is sigma by 2 epsilon naught, and sigma is q by a, right? So sigma by 2 epsilon naught into q, so it would be q square by 2 a epsilon naught. So if I have to just write this, it would be 1 by 2 pi r square epsilon naught into pi r square v d into pi r square vd. So if I calculate this, just a minute, it would be, okay, sorry, there is a epsilon naught here as well, so there would be epsilon naught square also here, and so my answer would be half epsilon naught pi capital R square v square by d square. So this is correct. This first option is correct. My expressions are matching, so first option is correct. And now when the disk is placed on the bottom plate, the charge q on it is this. Okay, so what happens when we place this disk, the small disk here? Let us see. So this is my plate. This is my capacitor plate which was given to me. So let us say we zoom into it and we see this plate which was given, right? So what happens is when we keep this new disk at the center, it was given at the center, right? Just a moment. Given the center. So thickness, which was t, is very small. So what we can assume is that it is completely like just on the surface of the plate, and we can't see any kind of non-uniformity because it's so thin, and even the radius r is so small. The small r is so less that we don't find anything difference. So the charge distribution, when we keep this two conductors together, the charge distribution would be How? Just let's see. There is another capacitor plate which was there at the top. All right. So when the plate was somewhere like here in between, say, what would happen? The charge induction would be, because see, this is my minus q and this was my plus q. So the charges here would be plus 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 and minus 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 induced, right? So this is minus 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 here on the surface, and this is also minus minus minus. Now when this plate is kept here, what would happen, that whatever charge minus charge was here in this plate before, like keeping this plate, would now come to this surface, because now this has become like a part of the plate. All right, you can understand. This has become a part of the plate because it is so thin, and it's looking like it is a part of the plane. And also you can see from this logic that if this plate is kept here, then this plus and minus charges would basically cancel out, and this only thing which you can see on the surface is this minus charges, which is the same induced charge. So basically this thing will only happen. The only charge you can basically see is this minus charge on the top of the plate, and we forget these charges. Just a minute. We forget these charges here. Yeah. So the only charge that will be residing will be on the surface of this plate. And easily we can see, since the charge has to be conserved in this entire system, right? This has to be totally minus q. So what we can see, if the charge on this plate is basically small q, so q has to be equal to capital Q by total area A into the small area which is A here, right? So my capital Q was pi r square epsilon naught V by D, and the total area is pi r, capital pi r square, into pi r small r square, right? So this would be equal to basically epsilon naught V by D into pi r square, and since this is negative charge, so q will be negative basically. But there is a half here which is incorrect, because there should not be any half, as I feel. I hope this is not correct. Okay, so this option is incorrect. Now let us see what the other options say. To lift up the disk at rest initially in presence of a uniform gravitational field G perpendicular to the plate, which is acting obviously downwards, the applied voltage has to be increased beyond the threshold voltage Vt, where Vt equal to this. Okay, let's check. Yeah, obviously it has to be increased upon a certain voltage, because just see, this is the plate which we are talking about. We are now just looking about the plate only. We forget the disk. So there, what are the forces acting here? There is an electric field obviously coming from the upper disk, which is equal to sigma by 2 epsilon naught, right? And this electric field is causing because since the charges is negative, this electric field is causing a electrostatic force upwards. There is a normal acting upwards, and there is a weight of this plate which is mg downwards. So you can see, for leaving contact with the disk below, n has to be 0, and this is only possible if E is greater than equal to mg. Am I right? F is greater than equal to mg. Now F is what? F is QE. Am I right? F is QE, and this sigma, which is the charge, is dependent on two things. The Q and E is both dependent on the voltage V, because, well, I mean, Q and E composed of an expression of capital Q which is dependent on capital V. So we have to change voltage in order to do all these things. So my force here is QE greater than equal to mg, and if I write the expression of force which we already obtained here, yeah. So just let us do it once more, because this is Q, capital Q, which is Q by A into small a into electric field is Q by 2 epsilon naught. Alright, this is greater than mg, and for this we need to do is, uh, just a minute. this has to be greater than mg, right? Okay, so what was my okay, so what we can do here simply is we can my q was pi capital R square epsilon naught v by d. So my q by a is pi R square, I'm sorry, q by a is v by d epsilon naught. Am I right? So q by a square is v square by d square epsilon naught square into pi small r square into 1 by 2 epsilon naught greater than equal to mg. And let us say this voltage is Vt, which is the threshold voltage. So my Vt square, epsilon, just cut the epsilon not here. So my Vt square is 2 mg d square by pi small r square. So Vt, or my threshold voltage, has to be equal to root 2 mg d square by pi small r square. Am I right? So 2mg d square by pi small r square under root of this whole expression is my threshold voltage. Just let us check if it is correct or not. Okay, there was one epsilon also. Okay, so epsilon would come here. So this is epsilon naught also. Okay, let us just check the expression. 2mg d capital D square, sorry, small d square by epsilon naught pi capital R square. So it is wrong because we had small r there. So this is also wrong. Okay, now let us analyze the last option. When V is greater than Vt, the disk undergoes an up and down motion and eventually comes to rest. Okay, so obviously what you can see is if I increase the voltage above the threshold voltage, obviously this electrostatic force would be increasing, and at some point it will lose contact and this disk will move upward. All right. Now, when this disk will move upward, what will happen when it reaches the topmost disk? Nothing. The same way which we did in the bottom, for the bottom capacitor plate, it will also be like the same in for the upward plate, because there will be negative charges induced. There will be positive charges induced here, and there will be negative charges induced here, and obviously the top plate has positive charges all over its surface, which is Q. So similarly, it would get like come in contact with that, and the charge distribution will occur in the same way, such that you don't feel any separation. Like it would be just a single plate with the very thin small circular plate over it, and the surface charge, the positive surface charge of the area, would come over that small plate, and it would behave as a singular plate or a single system, right? So the whatever thing the charges would be there would be, the charge distribution would be similar way in what we did for the lower circular plate, right? So the charges would be coming like this. Similarly, Q expression would also be same, just the sign would be plus, positive. Q would be same. So now what are the forces that is acting here? Here mg is also acting downwards. Am I right? Electric field due to the bottom plate is in the same direction this, and since it's a positive charge, so my Fe would be also acting in the same direction, which is downwards, and my contact force is also in the same direction, which is the normal is also in the same direction, which is downwards. So each and every force is downwards, and easily this plate would come again down and it would be accelerating downwards. So here it was accelerating upwards when it was at the bottom plate. It was accelerating upwards with some say acceleration a, and similarly when it would be coming downwards, it would be again accelerating with some acceleration, suppose say a dash, when it would come with the contact with the above plate, and then again similarly when it will be coming downwards, this over and over again the same process will occur, the same charge distribution will occur in the bottom with the bottom plate as well. And then after some point when where voltage is increasing, like when the voltage, because this voltage is already above the threshold voltage, so even at that bottom plate it would leave contact immediately when it comes downward. It will leave contact because the Fe is greater than mg. So it will again go above. All right, it would go above and again go hit the top plate, and this process would happen over and over again. There will be no stopping here. So the disk undergoes an up and down motion and eventually comes to rest is wrong. So the last option is wrong. What would happen is the only correct option in this question is basically option A. So we are done with the second section as well, which is the multi-correct answer type question. So let us move on to the next section, which is section 3, which is basically numerical value type, where you have to answer in like decimal points. All right, so we have to answer in decimal points here, and the marking scheme is +3 0, and you all know that those things, so I'm not going into that. And now let us move on to the first question of this section, which is this question 9, which says a ball is thrown horizontally from a tower of height h with an initial speed u0. For the resulting motion, the time taken for the ball to hit the ground for the first time after it is thrown is t1. Okay, so this point, in this point, this is t equal to t1, and each time it hits the ground, its vertical velocity instance reverses and decreases by alpha%. Okay, its motion continues for a long time as shown in the figure. If the duration of this entire motion is 91, okay, and the total time and total distance traveled by the ball in the horizontal direction is d meters, the value of alpha plus d is. Okay, for the entire motion it has been said. So this, let us say this is t equal to t2, and then obviously t equal to t3, and so on, and up until unless total motion occurs is 91, right? So let us see one thing first, that when this, let us analyze this motion first. When this ball is coming with when it is projected with horizontally with speed u naught, this horizontal component is always going to stay same. Am I right? Here also it would be u naught. Here also it would be u naught. Here also it would be u naught. All right, but since there is acceleration due to gravity downwards, so here would be some v when it reaches this point, and this you all know would be under root 2 g capital H for the, because the height is small h, so you all know the speed would be something like this. Am I right? 2g small h. Now since there is some coefficient of restitution here e, for which the speed is getting reduced by alpha%, so we know after it bounces off, the vertical component will change and it would become e into v. And right, am I right? E into v. So basically, if it is getting decreased by alpha%, that means EV is basically 100 minus alpha into 100 by V, or 1 minus alpha by 100 times V. So my coefficient of restitution can be related with alpha as 1 minus alpha by 100. Am I right? Yeah. So again, notice one thing. Since it was EV, we know in projectile what happens is the vertical component initially and finally would be same, just the direction would be reversed. So here it would be EV again, right? It would hit with EV, and when it bounces off, it would again be multiplied with another E, so it would become E square V. Similarly, E square V and E cube V. Okay, so notice one thing, since the horizontal component of velocity is not changing at all for the entire motion, so the distance which has been traveled by in the entire motion, the horizontal distance which is traveled in the entire motion, will be simply basically u naught into total time of the projectile of the motion. So we can easily write that d, which was the total distance, horizontal distance traveled in the entire motion, would be equal to u naught into 9t1, that is the total time. So this is done now. Now also we know what is T1. T1 is basically under root 2h by g. We can calculate easily. Now T2 is nothing but for this the total time period for this entire motion. Am I right? The total time for this entire motion would be nothing but 2 into EV by g. Am I right? It will be 2 into EV by G. So, and T3 would be similarly 2 into E square V by G. So if I actually try to sum all this up, so 91 would be basically equal to the sum of T1 plus T2 plus T3 plus so on. Let us say this would be equal to under root 2H by G plus 2EV by G plus 2 E square V by G plus dot dot dot. Alright. And it has already been said in the question that the motion or the time taken for the, okay, just wait. So the motion continues for a long time. Okay, and this long time has been given as 91. So this motion continues for a long time, so we can easily say that this series basically goes on to infinity. Am I right? Yeah. So what we can do is 9t1 is nothing but root 2h by, since this is also t1, this term is also t1, so we can do is t1 plus 2v by g e plus e square plus dot 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 up to infinity. So this is a gp. So 8t1 equal to 2 by g into 2g small h, and it is e by 1 minus e. Easily we can say that this gp. So now what we can do is, so this term right here is what? This term, if if I take g inside here, it would become basically t1. So this is 8t1 equal to 4t1. Sorry, 8t1 equal to 2t1 into e by 1 minus e. So e by 1 minus e is nothing but 4. And if I solve from here, I would get e as 4 by 5. Right. So if my e is 4 by 5, from here I can get alpha as well, the value of alpha. Right. I can get the value of alpha, which is 1 minus alpha by 100 equal to 4 by 5. So therefore alpha equal to 20. Now also what I can do is I can get the value of d directly from here, because I have, okay, let me just calculate t1, 2h by g. I have the values here, which is 2 into 44.1 by 9.8, 44.1 meter, 9.8, and u naught has been given as 10. So it is 10 into, just let me calculate here. So it is 4.9, and yeah, so this is going to come probably, let me calculate this here, 4.9, and if I just do it, yeah, so this is going to come 3 seconds. So this is 10 meter per second, and this is equal to into 3, which is, okay, 91. So 9 into 3 is 91, so 9 into 3, so this is equal to 270. So alpha plus d is nothing but 20 plus 270, that is equal to 290. So my answer for this question, which is I had to calculate alpha plus d, has to be 290. This is my answer. Okay, so let's move on to the next question. This is question 10, which says a solid metallic sphere of radius r is cut into two identical hemispheres. The cut surface flat is coated with a thin insulating layer of thickness d, which is much smaller than r, and the two parts are put together back. One of the hemispheres is then given a positive charge plus q, while the other one remains neutral. If the electrostatic force between the two hemispheres is this, we have to find the value of n. Okay, so let us analyze this question. I had I had a hemisphere, say, and which is of the radius r, and then we just cut it from between, and we insert, basically, or we, since we are coating it with some insulating portion, so basically what we are doing is, basically you can understand it as inserting of a insulating material in between these two hemispherical parts, right? it has the same, it carries the same meaning. So let us say this is some insulating part that we have already like inserted here, we have quoted here. All right. So this is the insulating part, and its distance has been given as d, which is very small. So basically, what is happening is, if I take one half of this sphere, let us say we have also given charge to this side q, and this is neutral, so 0. So what happens here is, very carefully notice this. Okay, I'm drawing it part by part. Now I'm drawing it part by part to make you understand. Okay. So this is my other hemisphere, and this is my insulating coating, or whatever you can call it, whatever you like to call it. Yeah. Okay. So this is my the coated part. So if, and as I know, in conductor the charge resides only on the surface. So since if it was the q charge overall in this entire part, and so I can divide it like this, that I can say that small q charge exists on this flat surface, and then the charge existing on this curved surface is q minus small q, capital Q minus small q. Now this system, due to the charge q here and the small charge q here, there would be some my charge minus q induced in this surface of the dielectric, the insulating material, and plus q would be induced here, and similarly minus q would be induced in this flat surface of the hemisphere due to the contacts and the closeness, the proximity, and the law of charge distribution basically, and plus q would be induced on the flat and the curved surface to maintain the neutrality of this hemispherical part. All right, so this is my charge distribution scenario. It's quite similar to how we do in capacitors, right? So now let us try to analyze the relation between these two charges, capital Q and small q. Okay, so uh, just carefully see this. These two flat surfaces of both the hemispherical part are very close, because small d, which was the distance, is much less than r, and it just behaves like two capacitor plates closing in each other. So if I say there is an electric field within this dielectric, which is basically responsible for polarization of the dielectric, this E would basically be equal to delta V by D. Am I right? And delta V, that potential difference between these two hemispherical spheres, will be basically equal to E into D. Now, since D is very small, which is tending to 0, I can say that the potential difference between these two hemispherical parts is basically 0. So again, the condition of conductor is maintained, because we know the entire metallic sphere was a equipotential surface initially. Delta V was 0. But when we cut and insert the dielectric, the problem was there that there would be a change in potential due to the presence of dielectric. But this is not the case, only because we have taken D is much less than R, and this condition makes it again the same thing, that both the surfaces of both the hemispherical part are in the same potential. And since this parts are on the same potential, which means the curved surface is also on potential V, the flat surface is also on potential V, this surface is also on potential V, this is also in potential V. Since all these surfaces are in potential V, I can clearly say the charges present on these surfaces of like for this hemispherical part, the charges present on the flat surface who has to be equal to the charge present on the curved surface. That's the law of conductors and charge distribution on conductors. So my q minus q has to be equal to q, and from here I can get that small q is nothing but capital Q by 2. So this is one important thing that we obtained. Now if I have to write the force, we basically know from here that the charge here is q by capital Q by 2. This is minus q by 2. This is again plus q by 2, and this is minus q by 2. Okay, so for these two spheres, we can essentially write the repulsion force just same before as we did, nothing different. There would be there would be some repulsion force acting on both these spheres as spheres. And how did we write this force? How do we write the force on any kind of conductor? That would be simply like this. If I have a conductor like this, and if I consider a small area patch like this, the vector is dA, and I can write the electrostatic pressure as PE. So the force is basically PE into dA, and electrostatic pressure as calculated is sigma square by 2 epsilon naught, if sigma is the local charge density here. And this is easily which is derived, so I'm not going to the derivation. Similarly, for this part, if I take a patch here dA, the area vector would be somewhere like here dA. So it will have two component, a horizontal and a vertical component. And similarly, if I symmetrically take another patch here in this direction, which is having dA, it would have a horizontal and a vertical component similarly. So basically, the horizontal components would stay and the vertical components would the vertical components of the area patches would basically, when you vector sum all of this and over the entire hemispherical surface, the vertical components would remain and the horizontal components would vanish or cancel out each other. That's why we basically take the projected area when we are calculating for the curve part. So the force on the curve part is basically sigma square by 2 epsilon naught into the projected area, which is pi r square, right? And sigma is nothing but this entire sphere, the charge distribution on this entire sphere, sigma was capital Q by 4 pi r square. Am I right? Now for the flat surface, there will be also a force. But now my flat surface, as I told you before, due to the charge distribution and the very small d, it is basically acting like as capacitor plates. Alright. So the force here, if this has a repulsive force like this, which is F curved, the force of the flat surface, since it is minus q by 2 and this is plus q by 2, it would be attractive force in this direction. This would be the force of flat surface would be in this direction, F flat, and it would be basically equal to the ways we write the force for capacitor. It would be just the same way. I can write like this. So my sigma here is q by 4 pi r square. So it is 8 pi r square epsilon naught into q by 2. So it is q square by 16 pi r square epsilon naught, my flat surface. And for this I can easily find out that it is q square by, it is 4, since it is 4 pi r square 16, so 32 pi r square epsilon naught. You can easily find this out. So and this is my two forces, and if I find the net force, because I have to find the net force, which would be equal to q square by 16 pi r square epsilon naught minus q square by 32 pi r square epsilon naught. Yeah, so I made a mistake here, because sigma here, the sigma is different. This is my sigma dash, which I am talking about the flat surface here, right? So sigma dash, because I'm not talking about the two capacitor plates. So this is sigma dash, the the distribution, the charge density at the flat surface. So sigma dash is different. Sigma dash is my q by 2 by pi r square, right? So it is q by 2 pi r square. Sigma dash is q by 2 pi r square. So here it would be changed. It would be 4 pi r square epsilon naught. So it would be not be 16, it would be 8. Yes. Yeah. So now I can do this similarly. It is 8 pi r square epsilon naught. So my answer would come out to be 3 square q square by 32 pi r square epsilon naught. And if I take k equal to 1 by 4 pi epsilon naught, this is basically equal to 3kq square by 8 r square. Am I right? So my n n is basically equal to 8 by 3 because I had n at bottom, so n equal to 8 by 3, which is basically equal to 2.66 or 2.67, whatever you like to give the answer as. So I would write as 2.66, the answer for this question. Okay, now let us move to the next question, which is question 11. A rectangular wave pulse of width 0.4 centimeter is traveling to the right on a taut string of linear mass density mu1. Okay, so this is mu1, and as to another taut string dash line of linear mass density mu2. Okay, the tension in both the strings is same. Nice. So this is t, this is t. So we can easily relate the velocity v1 if here it is v1 and if here it is v2. So we can easily relate by v1 by v2 equal to root 2 mu2 by mu1. We can easily relate this because v is nothing but t by mu. Okay, so tension in both the strings is same. If the transmitted wave pulse has a width 0.6 centimeter, the ratio mu1 by mu2 is okay. So my transmitted wave pulse, if it was generated here, this is a width of 0.6 centimeter. So why this increase of width is happening? First of all, let us understand. See, when this wave pulse reaches this junction here, which is 0.4 centimeter still, the first end now travels with a velocity v2 because it is now going into the medium, but this end still travels with a velocity v1. So with each and every time passing, there is an increase of length as v2 minus v1 by into t. All right, so this delta L we already have as 0.2, and what is this time t? By the time t is the time taken for this end, for the last end basically reach the boundary or reach the junction of the surface. Am I right? Yeah, this is a good color. Yeah, so it reaches the junction of the junction at time small t. So basically t is equal to 0.4 by v1. So this expression or this equation can be written as 0.2 equal to v2 v2 minus v1 into 0.4 by v1. So I can write 1 by 2 equal to v2 by v1 minus 1. So v2 by v1 equal to 3 by 2, which is equal to root mu1 by mu2. Therefore mu1 by mu2 equal to 9 by 4. So by mu1 by mu2 equal to 9 by 4, and 9 by 4 is equal to approximately like 9 by 4, not approximately, it is exact only, it is equal to 2.25. Okay, so answer for question 11 is 2.25. Okay, now this question, in the final answer given by Iit Kanpur, this has been dropped. And why it has been dropped, that's the reason is it uses something which you don't generally use in your rotational mechanics, which you read in class 11th. The concept that has been used is basically composed of the material physics or elasticity, and the concept comes from there when we talk about the breaking and bending of rigid bodies and the rotational effect due to that. So these things are not taught in your JEE syllabus. That's why this question was basically dropped in the answer key. This requires solving with the help of a concept known as bending moment. Whenever we talk about breaking of rigid objects and its rotational effect, we always consider this parameter, which is bending moment. And this concept is not taught in class 11th or 12th, not even in the chapter when you should study elasticity and all. So if I'm not going for the solution of this question in this video, if you want the solution of this question, I will make a separate video for this. But this, I don't think this concept would come in tomorrow's exam in JEE Advanced, because this has, if even if this comes, then I again similarly this would be dropped just as it has been done in the sample paper as well. Okay, so let us move on to question 13. So this is a question from optics. the first question that I encountered from optics. So the consider a concave mirror and a convex lens, refractive index 1.5 of focal length 10 centimeter each, separated by a distance of 50 centimeter in the air, okay, and which obviously refractive index is 1 for air. An object is placed at the distance of 15 centimeter from the mirror. Its erect image is formed by the combination of these two, the lens and the mirror, and the first magnification is m1. And when the setup is kept in the net mag, this is the net magnification of the total setup. Now the setup is kept in a medium of refractive index 7 by 6. Okay, we change it from air to this medium. The magnification then becomes m2, the net magnification. So we have to find the ratio of the net magnification. Okay, so since this setup, image will be formed by both this mirror and the lens. So my capital M would be of the form m1 into m2, the magnification by the mirror, the reflection by the mirror, and the magnification due to refraction by the lens. But notice one thing, due to the change of medium, nothing would, it would not affect, basically it would not affect the formation of image by the mirror, because there is no relation with the medium here, so on. So basically the first reflection would stay intact, and let us say the image which was formed is here somewhere. Let us say this is the v. So we can find the v. Obviously it is 1 by v minus, sorry, plus, because due to the mirror we are doing for the mirror, 1 by v plus 1 by u is minus 15 here, and 1 by f, since it is concave lens, so f is 10 here. So f the focal length is minus 10 because it is concave, and f is 10 centimeter here for air, right? So for that we also need to find f in the given medium, f in the new medium which has been given, and this we can find. And for to find this, we need to have the knowledge of the radius of curvature of this lens, right? And that we can find out from here. All right. So we have an entire mapping of what we have to do. So 1 by v plus minus 1 by minus 15 equal to 1 by minus 10, which was my focal length for the concave mirror. So from the first reflection, we can easily see, if we solve this, this would come out to be so this would come out to be minus 30 centimeter. So my image, which is by the first reflection, is formed somewhere here, 30. So the object distance u for the reflection for my refraction through my lens would be, in both the cases, would be 20. I mean, it is better to say with sign. It will be minus 20 centimeter, right? So now here you can easily see that m1 is basically minus 2, but we don't need this, because by when we do m2 by m1, the first reflection is always going to stay same. So m1 is same in both cases, right? So what basically what we'll be doing is we will be doing the ratio of magnification for the lens part. So we are concerned about only the now we consider about only the reflection through the lens. So first we need to, for that we need to find uh the radius of convergence, so that we can find the focal length in the next medium. So f is, if I talk about the air, it is 10, and it is mu medium by mu lens, because we know mu medium by mu lens. Mu medium is mu lens by mu medium minus 1 into 1 by r minus of 1 by minus r, when we are talking about the lens, convex lens. So this is 10 equal to 1, mu lens is 1.5 by 1 in air minus 1 into 2 by r. So from here we can easily find out that this r is 10 centimeter. All right. So in the new medium, if we need to find the focal length, we would essentially see that f is basically mu lens by mu medium minus 1, 2 by r, that is 2 by 10. So mu length is 1.5 and mu medium is 7 by 6, which is given already, minus 1 into 2 by 10. So this thing right here would turn out to be what I guess is 2 by 7 into 2 by 10. So this is 4 by 70. This thing is 4 by 70. Sorry, I made a mistake. Yes, yeah. Okay, this is 1 by f, right? And this is also 1 by f right here. And this is not 10, this is 1 by 10. This is also 1 by 10. Yeah. So r is 10 centimeter here. So this is 4 by 70. So this is my 1 by f medium, which I was talking about. So let us now do it for the air medium. Let us find the M2 magnification value. So this is 1 by V minus of 1 by U, which is minus 20, and 1 by F. Now since it's convex, so we have plus positive focal length, well, positive F value. So this is 10. So from here we can get V as 1 by, sorry, V as 20, right? So we can get V as 20 from here. Now if I talk about the medium here, in the medium, so okay, here in air, the magnification we find out M2 to be V by U, which is 20 by minus 20. So basically this is minus 1. Magnification is M2 is minus 1. So now in the medium, we find out 1 by V minus of 1 by 1 minus 20. And this is 1 by F medium, which I find out to be 4 by 70. So 1 by V equal to 4 by 70 minus 1 by 20. And this would turn out to be, let us see, this will be, yeah, so this would be 1 by 140. So V is basically 140 centimeters. So magnification, now the new magnification in the due to the refraction is V by U, which is 140 by minus 20, and it would be minus 7. So my ratio of magnifications, as I already mentioned, M2 by capital M1 is basically M2 dash the magnification due to new refraction, new magnification due to refraction M2 dash by the old magnification due to the refraction through lens M1, small m2, sorry. Yeah, this would be equal to minus 7 by minus 1, so 7. So my ratio is equal to 7. You can see the entire process. It's also very easy question. So my answer to this question is 7. Yeah, the answer to question 13 is 7. So let's start with the question number 14 in section 3. So this says, in the circuit given below, the switch S closes when VC is greater than 2V by 3 and opens when VC is less than V by 3. The variation of VC with time is as shown in the graph below. So the period T of the waveform is nRC, where n is. Okay, so importantly, this is when switch closes, S closes, and this is when switch opens. Okay, and it has set the period T. Now this is the period T, right? So I can also write T as in a different format. I can write see, this is the period T as we know waveform from one crest to another crest, right? If this is T waveform, I can also say that from this point to this point, this is also T, this is 0T, right? And this right here, see, when V is greater than VC by 3, it has been said that the switch is open. So at this phase, the switch is open at this point. So let us say that time switch was open for time T1. And when just at the moment when VC comes to 2V by 3 and it starts to increase, then the switch becomes closed. Now, due to discharging of the capacitor, the voltage could not increase more than Vc, or which is 2V by 3, and thus then starts to decay. let us say that the discharging period is of time t2. So the time period is basically equal to t1 plus t2. Now let us focus on the switch when switch is open. Let us focus on the period when switch is open. All right. When switch is open, we have this entire circuit and we forget this part, right? So the charge flows occur in this direction, and this is the charging phase. Charging of C occurs. In any transient state, we can write Q for any RC circuit. In any transient state, you know Q, general expression of Q can be written as A plus B e power minus T by tau, where tau is its time constant. So here tau is R1 plus R2C, because we have the whole circuit now charging. This is in series connection, R1 and R2. All right. Now, we let us have some condition. For t equal to 0, we know Q is the voltage here at t equal to 0 is V by 3. So Q is CV by 3. At t equal to, so from here what you can say, that Q equal to CV by 3 at t equal to 0, which is basically equal to A plus B. And at t tending to infinity, if this was kept for a long time and it is led to achieve steady state, then Q would have been the entire potential difference, voltage difference across the cell. It would have been across this capacitor, right? So this is this basically is CV, which is equal to A. So from here I can say B is minus 2 CV by 3. So the expression of Q is easily you can write CV minus 2 CV by 3 e power minus T by tau. Now uh, now let me write one thing. So we know at t equal to t1, Q is 2 CV by 3. So it is CV minus 2 CV by 3 e power minus T by tau. So from here, if you solve the equation, you can see that T1 equal to R1 plus R2 C ln2. Now, it has already been given that R1 is R, R2 is, I guess, 2R. Yeah. So this is basically equal to uh, 3R in C into ln2 is 0.7. So it is 2.1 RC, right? So this is 2.1 RC. Now I have to find when S is closed. So when S is closed, just see one thing. When S is closed, this point right here is 2 at 2V by 3. The voltage is 2V by 3. Okay, just know this switch is called as voltage regulated switch, which it depends on whose closing and opening depends on voltage regulation. This is called voltage regulated switch. All right, this is voltage regulated switch. Now when this switch is closed, this circuit which is outside is actually short circuited by this connection. So when this charged capacitor, which is already having the charge 2 CV by 3, will now starts discharging inside this circuit only, within this short circuit. This capacitor would charge this would start discharging. That is the graph showing decay rate in the voltage of VC here. So it is discharging, and if it's kept for long time, you can see that there is no external EMF acting here. So if it's kept for long time to achieve steady state, this in this circuit, the capacitance charge on the capacitor would become zero eventually. So similarly, we can write the transient state equation here, which is Q equal to A plus B e power minus T by tau. But here the tau time constant would only be R2C, because only the resistance R2 is involved in this circuit. So what we can say here is Q at t equal to 0 is 2 CV by 3, so which is equal to A plus B, and Q at t equal to infinity should have been 0, which is equal to A, right? So now we have the equation, which is 2 CV by 3 e power minus T by tau, and Q at t equal to T2 should be CV by 3, which is again 2cv by 3 e power minus t by tau. So my tau, my t2 from this equation would come out to be R2c ln2, which is equal to 1.4 Rc. So therefore my total time is basically equal to 2.1 plus 1.4 Rc, which is 3.5 Rc. 3.5 Rc. Right. So my answer to this question will be 3.5. That is the period of the waveform. Okay. Now let's move to the next section, or it's the last section of this paper. That is section 4, which has non-negative integer type questions. The instructions is very clear. There are two paragraph like questions. In each paragraph there are two questions, and marking scheme is +4 and 0. Okay, so let's move on to the first paragraph, which has the entire diagram here. A thin rod with length L, mass M, uh, in uniform density lies on the y-axis with its midpoint at the origin, and a point object O with mass m travels with velocity u in the positive x direction and hits the rod with impact parameter h, where h is obviously within the rod only, lying within the rod, and the collision is perfectly inelastic, which means E equal to 0, and it sticks, ball sticks with the rod after collision. So the first part, let us solve the first part. Okay, let us make the FBD and all, everything. Here the rod is there. Let's say the mass or whatever there was, yeah, the mass M is coming with speed u, and from the center it is at some height h. From the center it is at some height h, and after it comes, it sticks with the rod. Okay, after the collision, the center of mass of the system would lie somewhat here, because this rod is also of mass m. So after collision, let's say if it gets collided here, so the center of mass would lie here at point C. And let's assume that the velocity of this combined system after collision becomes v. And about this point, there would also be a uh, angular velocity, let's say omega. Okay, so if h equal to L by n, the velocity v of point C at the top end of the rod. Okay, so let us name the center of mass as O, and this is point C at the top. At the top end of the rod, just after the collision between A and the rod is 0. Okay, the velocity at point C must be 0, it has been said. So this is Vc, say. This is equal to 0. In such a case, the value of n is okay. So let us, after the collision, as I said, let the velocity of new center of must be v, and the, the angular velocity obtained due to this collision, let's it be v. So we can write two equations. By momentum conservation, we can write mu equal to 2mv, and v from here would be u by 2. Now let us at about point O, you can see for this entire system, about point O, are there any external torque? So about point O, there is no external torque in whatsoever. So what we can do is basically conserve the angular momentum about the point O, because there is no external torque. So let us do that first. This is, if this is h, then obviously this length is h by 2, right? So the initial angular momentum is in this direction. So let me say the direction also. This is my positive direction. I'm taking this as positive into the paper. So mu h by 2 must be equal to the uh, the angular momentum of the rod, because I'm considering the point O, which is the center of mass of the system only. so I don't need to have the consideration of the velocity of center of mass, because it is not, we are not taking any other point other than the center of mass. So this point O, okay, one thing to remember is this point O which we are taking, we are basically taking not on the rod, we are taking as a stationary point on the ground. If we have taken the point on the rod, then we couldn't have wrote this equation, because then the action of pseudo forces would have also come. So this is stationary point on ground. Just below the point C on the rod, there would be a projection of point C on the ground as well. So we are taking that point. This is a very important point to remember while we are conserving angular momentum and writing all these equations. Okay, so mu into h by 2 must be equal to the moment of inertia into omega. So moment of inertia here is m h by 2 whole square plus m into h by 2 whole square plus m l square by 12 into omega. So I can write m u h m u h. I can cut all the m part, and I can write h square by 4 plus h square by 4, so h square by 2 plus l square by 12 times of omega. So my omega comes out to be this, whatever expression, big expression is here, h square plus l square by 6. So this is my omega. All right. Now, what do I need to find? Okay, so I need to find VC. So if I write the expression of VC, what would be the expression of VC? It would be V plus L omega by, sorry, not L omega. This length is what? This is h by 2. Okay, this length is L by 2 minus of h by 2, right? So L by 2 minus of h by 2 into omega. I mean, this length right here is L by 2 minus of h by 2, right? So this is L by 2 minus h by 2. Now V is u by 2 plus L by 2 minus of h by 2 omega must be equal to 0 as per the question. So, so if I substitute omega here, what would I get? U by 2 plus L by 2 minus of h by 2. Okay, let me put this here. Sorry, let me put this here. Yeah, so L by 2 into h square plus L square by 6 equal to 0. So from here my equation would come, if I cut u from both the part, my equations would come as, it's quite big to be honest. L by, I have to simplify this question, this equation a little bit. If I take this side, it would be half equal to h by 2 minus of L by 2 into h square plus L square by 6. So h square plus L square by 6 equal to h by, sorry, you would not be here, right? Yeah, so it is h square minus hl. So from here the equation would come as uh, h equal to L by 6. So my n value is 6. All right. So I have the answer to the first question, or which is question number 15. It would be 6. The first question answer to the paragraph type is 6. All right. Now let us go to the next part of this paragraph type question. It has said, to go in question number 60, it has been said if H is equal to L by 4, the total kinetic energy just after the collision between A and the rod is 7 m square by n, where n is this. Okay. Okay. So what is the total kinetic energy of the system after collision? A after would be half total mass of the system into VCM square plus half moment of inertia of the system into omega square. Very simple. So let us do it. Half 2m, it is time u by 2 square, plus half moment of inertia is m h square by 4, similar in the similar way which we wrote, plus ml square by 12 into omega square. Okay, if you want to know how we are writing the moment of inertia, it is just because we will have m collided here and center of mass is here. So the moment of inertia of about this point, let us see the moment of inertia about this point IC, the contribution to due to this rod would be ml square by 12, its own moment of inertia about its own center of mass, and then shifting it by h by 2 distance, and also adding the moment of inertia to this collided wall, which is also at h by 2 distance, and mass is also m, so mh square by 4. So this is the entire moment of inertia of the system, the way we are writing this here. Okay, so it is mu square by 4 plus uh, mh square by 2. So it is mh square by 4 plus ml square by 24 into omega square. So okay, let's now find omega. What is omega? Omega is, as we obtained here in the first part. So omega was already obtained by us in the first part. So that is omega equal to uh by h square plus l uh by h square plus l square by 6. And we already have one thing, that is l equal to h equal to l by 4. H equal to L by 4. So if we substitute that here, we would get omega equal to mu L by 4 by L square by 16 plus L square by 6. So what would we get here? Calculations are there. 48, 8 plus 3, 11, and I think 12 u by 11 L, most probably. This is my omega here in this question. 12 u by u by 11 L. So if I continue this here, ms square by 4 plus mh is L by 4, so I can write ml square by 64 plus ml square by 24, and here it is 144 mu square by 121 L square. So if you solve this right here, you would get 64 is 16 into 4 and 24 is 6 into 4. So for common term, what should we do? Just this question is just like calculative, nothing else. Okay, we can do is 48 into 4, so it's 16 into 4, so 48 3 plus 3 and plus uh 8, so it is 11 ml square, and this is 12 into 12 u square by 11 into 11 l square. So I can cut 111 out from here. So I can cut 111 from here. I can also cut 4. I can cut 3. So it would turn out to be mu square by 4 plus 3. Okay, L square also we can cut 3 mu square by 44. So it is 14 mu square by 44, or it is 7 mu square by 22. So answer my n, capital N, is 7. 7 mu square by 20. So sorry. My capital N is 22. 7 is mu square by 22. So my capital N must be 22. So this is 22. Answer to question 16 is 22. Okay, so let's move on to the last paragraph type question. So this paragraph says, consider two insulated vessels containing equal mass m of water. Okay, nice. The vessels are connected by a conducting rod through which heat energy can be transferred only along its length. Nice. from one vessel to another. Initial temperature T equal to time T equal to 0 of the water in the vessels are 100 degree and 0 degree. Okay, so T naught here is 100 degree centigrade, and T naught, let's say, uh, if I have to say this like this, the T naught initially at hotter side is 100 degree centigrade, and T naught at colder side is 0 degree centigrade, which is at time T. So T naught C is 0 degree centigrade as shown in the figure. So LKA, everything which you need is given here. So first question is the time after which the temperature difference between the vessels become 50 degrees centigrade is T at this, then the value of alpha is. Okay, nice. So to do so, let us understand at time T what happens. Let us at general time T, the temperature of this hottest side is capital TH and the colder side is TC. Okay. Now at this instant, say in the next dt time interval, in the next dt time interval, the temperature of the hottest side reduces by dth and the coldest side increases by dtc due to heat transfer dq. All right. So I have two equations here. Key the rate, like the amount of heat transferred between these two vessels, we can easily write as dq equal to minus ms dth dt, sorry, minus ms dth, decrease at the hotter end and increase at the colder end. So from here we can find a relation that dth equal to minus dtc, isn't it? Which is very, by common sense also you can find it. So now we also have one equation which is due to the conduction of heat through the rod. The current, heat current, dq by dt, which is I, can be easily written as Ka, the temperature difference at that point of time was delta T by L. Now, temperature difference, this heat transfer happened due to which temperature difference? Not this temperature after the increase. It happened due to temperature difference that was just before the dt time interval. I mean at time interval T. So the temperature difference at that point was delta T equal to Th minus Tc. Due to this difference, this dTh and minus dTh and all has been produced. Due to this difference of temperature, this minus dTh of heat of temperature has been reduced, and dt and this temperature dTc has been increased in the other end. So this is my temperature difference, Th minus Tc. Now I can write Th minus Tc, or I can actually differentiate both of the delta T as also the temperature difference also, and I can write it as dTh minus dTc, and I can replace dTc by minus dTh, and so I can write this as d2 dTh. Okay, so if I write 2 dTh, and dq dt would can be simply written as minus ms dTh by dt. From here, from above, from this part, I can easily write this, right? And similarly, I can equate this as Ka by L delta T. And this is, if I write time here, if I like arrange this equation, this would somewhat be like Ka, and I can put dTh, like I can put this equation, I can replace dTh by d delta T by 2. So it would become d delta T by delta T. And now if I integrate this equation on both sides, it will from 0 to T, and temperature difference was initially T naught, which is, let's say T naught is 100 degree, and I want temperature to be T naught by 2, which is 50 degree centigrade. Alright, so from here I can say T equal to minus MSL by 2 Ka ln 1 by 2. Easily you can find. So T equal to MSL 2 Ka ln 2. So from here easily we can see that alpha equal to 1. So the answer to the first question is 1. Question 17. A very easy question also here. There is no like difficulty in here. So let us move on to the second part of this paragraph. Okay. The second question says if dq amount of heat energy flows from one end of the rod to the other end, that which we already wrote in the previous while solving the previous question, then the decrease in temperature difference of water in two vessels is. So the decrease in temperature is what? We are actually finding the rate of decrease of temperature difference, not temperature, temperature difference, which is delta T. So we already wrote d delta T is 2 dTH. And we also know that dq is nothing but ms dth, sorry, minus ms dth. So I can easily write dth as minus dq by ms. So d delta t is minus 2 dq by ms. And as it is already said in the question, we want to find decrease. So the sign is good. This would be minus. So beta is not minus 2, beta is only 2 because we need to find. We already said that d delta t is decreasing and the minus sign indicates that only. So beta is basically 2 and we are done with this question also. So it's very easy, just oral questions, the last two questions, it was very easy. And this marks the end of our solution video for JEE Advanced 2025 sample paper released by Iit Kanpur. Thank you. So we have come to the end of this video, of this long video, I would say. But I hope that you have all understood the solutions for all the questions that I've done for this video as well as the previous video for the first section of the paper. And I hope that you have liked the solutions. If you have liked the solution, please like, share, and subscribe my channel. And also, I will be posting more and more videos of interesting videos on topics which will be helpful for JEE 2026 aspirants as well, for the next year aspirants. But for JEE 2025 aspirants will be appearing for the exam tomorrow. I have a special message for you guys that I would just, as a senior, I would just say that who have also given JEE Advanced last year. So I would be saying that just be calm, just hold your nerves, and whatever you have done in these 2 years, just remember that you have to just go there and give your best. Nothing else. Don't figure about the results. Don't think about it. It will matter nothing. Because it is just going to make you nervous and it can harm your exam. So just stay calm and give your paper. Everything will be good. All the very best for JEE Advanced 2025 tomorrow.